Okay, good afternoon. Right, so today we want to finish our discussion on database designing. Okay, right, so let me open the note. Right, so we have discussed how to map uh, entities into uh, tables or relations. So then how to work with, and also the concepts related to primary key, and then the relationships and the concept of foreign key. So today we will concentrating on other advanced topics because we have discussed in the last class, we have discussed how to map one-to-one relationship, one-to-many relationships, many-to-many, right? In the case of both binary and unary. And at the end, we discussed how to design a ternary relationship. Of course, not only design, we even created using access. Right. So today, our task is, I'm not going to do any revision or whatever. Our task is a very small subtopic. Uh, Right. Relationships involving weak entities, and later we will look at how to model inheritance, right? Inheritance also. So these are some additional topics, but those are in your syllabus. Okay, right. And then we are done with designing also. Right. Relationships involving weak entities. So we have already discussed what is a weak entity. So weak entity is not major concept in our domain or business area, but we need to keep information about those entities also. For example, spouse of an employee, re- uh, parents of a student, okay? So that weak entity can also create a relationship. Of course, if it is there's no relationship, we don't keep that weak entity, right? And that relationship can be again one to one, one to many. Very rare, it is many to many, right? Very rare. It's usually one to one, no one to many. Okay. Right. If it is binary one to many, one to many, uh, so then obviously many side get the primary key, right? So that is how you do it. But if it is one to one, the weak entity will get the foreign key, right? Always weak entity get the foreign key because first we add the strong entity and then we add the weak entity. So therefore, always uh, when there's a relationship, okay, foreign key must go into the weak entity. That is ultimately what you need to remember. Okay? So this is an example. Say employee and dependent. So let's say we can have multiple dependents as well, or maybe spouse only, just one dependent. So then this is a strong entity. This is the weak entity. Okay. This is a weak entity. Okay, let's call it dependent rather than spouse. Okay, so that you can have many dependents. So dependence means spouse and children. So employee can have many dependents, many dependents. So then obviously foreign key must go into the many side as well. Okay, foreign key must go into the many side. And this case it is not an issue because anyway dependent is a weak entity. So remember foreign key must go into the many side. That is how you model one to many relationship. So then if it is one relationship is between strong entity and weak entity, other rule is foreign key must go into the weak entity. In this case, no conflict because your weak entity is the many side. So therefore, anyway, it's okay to have the employee ID in the dependent side because dependent is the many side and also dependent is the weak entity. Okay. So this is an example. It is just like normal one to many. Normal one to many, but there's a small difference here. Right? So usually you can make this primary key and this is just a foreign key in normal relationship. If it is strong, two strong entities, right? Like employee and department. But if it is a weak entity, obviously this is a weak entity, then you combine these two and create it as your primary key. So then this is your foreign key. This is your combined your surrogated key or whatever, and your foreign key combination is your primary key. Because if it is a weak tape entity, you need to combine the primary key of the strong entity as part of your primary key because it's weak. It's weak. That is a general rule. Right? If this is employee and department ID alone is the primary key, and the employee ID is the foreign key. Or if it is the employee and department, then employee side has the foreign key, and employee ID is the primary key, department ID is the foreign key. But here, employee ID is the foreign key, but dependent ID, employee ID combination is the primary. If you want, you can take dependent ID alone, but the best practice is always combine uh, your foreign key or the primary key of the strong entity as part of your primary key. Right? That is the best practice. Okay. So this is one to one. If it is one to one, remember in normal case, you can have the foreign key in any type, any table. But if that is when it is between two strong entities. But if it is between strong entity and weak entity, always foreign key must be in the weak entity. Weak entity. Okay. So again, there are two approaches. One approach is you take your primary key of the strong entity as your both primary key and foreign key of the weak entity. That is one solution. Right? That is one solution. So you take because remember the weak entity must have the primary key of the weak entity must be either primary key of the strong entity or it must be part of that. So therefore you can straight away take the employee ID as the primary key and also the foreign key. That is one solution. This is one to one, right? So the second solution is again combine. Again combine your its own primary key or its own unique key with the foreign key and make the combination as the composite primary key. Composite primary key. And make that at the same time make that your employee ID unique. Right? Not the primary key is unique. Anyway, primary key is always unique. Right? Now make your foreign key unique. Foreign key unique and make the combination as primary key. Those are the two solutions when it is one to one. Okay. Other solution is what? Just take the primary key of the strong table as the foreign key and make that foreign key primary key. It also works. This also work as long as you make your foreign key unique. So why do you make your foreign key unique to preserve one to one? Why do you combine your primary key as part of the foreign key as part of the primary key? Because this is a weak entity. Weak entity. Okay. So both solutions are correct. So in the exams, if there's a problem like that, you can use whatever the solution, or if there's a hint given in the paper, you can just use that hint and decide which one to use. Okay. Any questions? And of course, you don't get any questions related to many uh, relationship between strong entity and weak entity, because in reality also it's very rare, very rare. Okay. Right. So that is how strong entity relationship between strong entity and weak entity is handled. If it is one to one, there are two approaches. You can use whatever the approach. If it is one to many, of course, add your foreign key to the weak entity and make the composite primary key. Okay. So one to many, many is the weak entity. Okay. Right. Now we move on to our next subtopic under design. If you don't have any questions, of course, if you have any questions, I can answer, because this is very serious stuff. Serious stuff. Right. So at any time, if you have any doubt, or again, sometimes only you feel like, okay, now it's confusing. Don't worry, at any time you can ask. Right. Now let's move on to our next subtopic under design, integrity constraints. Okay. So what is mean by integrity? Constraint means restrictions, right? Constraints means restrictions. For example, in the road, sometimes you can see there are bumpers. So that is a restriction. That is a restriction. Okay. Restriction. So then what is mean by integrity? So integrity means it's not broken, right? It's not broken. There's a continuation. So but this is it. There's no integrity here. So this is broken. So then what is the connection of integrity and database? So remember, in databases we have different tables. So integrity means within the records there must be integrity, and between records also there must be some relationships, right? So that means it must be valid. Your data must be valid. Data must be related. That is why we have integrity constraints. Okay. Right. So we will look at four type of integrity constraints: entity integrity constraint, referential integrity constraints, domain integrity constraints, and other integrity constraints. Okay. But these two are pretty much we can take as the same category as well. Right. But both the first two are the most important. Number one, entity integrity constraint. So entity integrity constraint says the primary key field, or your primary key must have unique values for each and every record. The primary key must be unique and cannot be null. And this is enforced by database. You don't need to do anything. So every relational database enforce this. For example, if you have student table with student ID and name, where student ID is your primary key, your database will enforce that no two student IDs are same. If you try to do that, you will get error. At the same time, your database will make sure that null values are not accepted. Maybe null values are accepted for other fields if that field is null field, nullable field. But by default, primary key is not null. So that is why when we do SQL also, you will find that whenever we create a table, we will say primary key is not null. So what does the entity integrity constraint says? Your primary key field must be unique. No two values must be of the same value, and null values are not accepted for primary key field. Primary key field. Primary key or identifier. Okay. Is it clear? So that means if you have a table called bill, say bill ID is a primary key, you can't have bill with bill ID null. You can't have two bills with the same bill ID. You can have the same amount, you can have the same bill date, but not the same bill ID or bill number. That makes sense, right? Because otherwise it violates the concept of primary key. Second integrity constraint is called referential integrity constraint. Remember, whenever we created relationship last class using access, I asked you to tick enforce referential integrity. There was a tick checkbox. I always tick it. Right. So the referential integrity constraint says it's related to foreign keys or relationships. When you take a foreign key field, say there's a relationship between, say, employee and department. So then department ID is the foreign key because this is one to many. Right? So your foreign key field must have valid values, not invalid values. For example, if my department table has on department ID 1 and 2, you can have department ID 1, department ID 2 for your department ID field for the employee table, but you can't have something like 3 or 4 or something like that because there's no department called department 3. So because then there's no reference, valid reference. And also null values are allowed. For primary key fields, null values are not allowed. Foreign key, null values are allowed, but if you have value, it must be a valid value. So that means your foreign key field must have either valid value or null value. Valid value or null value. Valid value means that value must be already presented in the other table as a record or null. But you can't have invalid values. So that rule is again automatically enforced by your databases if you say enforce referential integrity. That is not automatically enforced, but if you ask database to enforce it, yes, it will enforce it. By default, it will not enforce it. That is why whenever I created database relationships last week, I ticked enforce referential integrity because it's not by default supported. And when we write SQL statements also, you will find that you need to write that as a part of your SQL when you create tables. Otherwise, by default, this is not enforced by your database unless you ask. But once you ask, database can enforce this. Is it clear? So if someone asks what is referential integrity now, do you have the words best or there's nothing called word best, either the correct answer or wrong answer. Right? So what is the correct answer? In database relationships, the foreign key field must have only valid values or none. It cannot have invalid value. Invalid value means a value which is not available in the reference table. There's no third value, but you have that. This is error. Okay. Now we have covered two integrity constraint. Entity integrity constraint, it says primary key must be unique and not null. Referential integrity constraint, it says foreign key value must be a valid value or null. Valid value means a value presented in the reference table. Right. So the third constraint is set of constraints, is a category of constraints. We call it domain constraints. So whenever we use the word domain means the business area, functional area, like financial domain, banking domain, education domain. Okay. Aviation domain. Health domain. So if there's a validation or restriction coming from the business rules of that business domain, we call it a domain constraint. Okay. For example, if you take education, remember education has students, courses, exams, results, and so on. So you know that in a typical scenario, marks marks is given out of 0 to 100. Typical, right? Maybe you can give marks 0 to 10. 0 to 5, but let's say typical. But anyway, there's a restriction, right? So that restriction is not coming from any other thing from your domain. Maybe it's a policy in your school. Marks is always given as between 0 to 100. So then a student cannot have mark in a database table. The mark field cannot have something like 112. That is invalid data. Mark cannot be -3. But if it is just the data field type is number or integer, there's a possibility that even by mistake, someone at -3, someone at 110. So we can restrict that. We can restrict that, saying the value must be between 0 to 100. So if you restrict like that, so then we say you have added a domain constraint. Domain constraint. Because that constraint is coming from your domain or business rules rather than relational database theory. Sometimes we need to set a fixed width, say credit card number. So credit card number has a fixed width. Right? NIC number has a fixed width. If at one character is missing, you know that that is invalid ID card number. If one character is missing or one or more characters are additional characters are there, then we know that that is not a valid credit card number. So those kind of constraints, we can set up those constraints, restrictions. If you set up those kind of a constraint for a particular field, we call it domain constraint because it's coming from domain, right? Credit card has a particular format. Marks must be between 0 to 100. It can vary between different institute, but they will have that policy. So we call them domain constraint. So we can't say what are those exact constraints. It depends on the domain, but you can define your own domain constraints so that you don't allow input of wrong data into your tables, right? Illegal data, invalid data. So there can be some other field level constraints. Some of these can be even related to domain as well, or not really related to domain, but still handy, right? So one such constraint is unique constraint. We already use that to create one-to-one relationship. So we can mark a field as unique field. It is not the primary key, but we can say it must be unique. Primary key is always unique by default. But a non-primary key field can also be make it unique. For example, we can say email field must be unique. That means no two students can have the same email. So that is a field level constraint. It can be coming from domain as well, but maybe not a domain. You just want to make it one-to-one relationship and so on. And another such constraint is null constraint. So null constraint means whether null value is allowed or not. Yes, by default, primary keys are not null. That is part of the entity integrity constraint. But if you apply it for other fields, say someone will say email can't be null, salary cannot be null. So then it's just a null constraint. Just a null constraint. Okay. Right. Any questions? So how many constraints we discussed? Entity integrity constraint, referential integrity constraint, some domain constraints, and some field level constraints. But those field level constraints can also be domain or not really domain, like null constraint, unique constraint, or domain constraints like credit card number field must have that specific bit. Marks must be between 0 to 100 and so on. A particular grade must be either A, B, C, D, or F, nothing else. Those are also domain constraints. Is it clear? I think this is our fifth session. So after today's session, we just have the SQL. Then we are done. Database is done. So then we have the programming. So now we are in the big guys, big guns. Programming, web development, database. Actually, those are the big topics. Programming, database, web development. The three technical guys. And we need database to do programming and web development because in web development and programming, we need to connect to database. From Python, we need to connect to database. From PHP, we need to connect database. So if you don't understand database, then you will not be able to understand programming and web development also. That is why these topics are sequenced in a particular way. Right now, we move on to our final subtopic under design, how to map inheritance. So remember, you in your syllabus, you have a subtopic called extended ER modeling. Right? That is support bit of object-oriented concepts in ER modeling. So we discuss that is under analysis. We discuss what is mean by overlapping in relationship or what is mean by disjoint. Now this topic is for those who have understood that. Okay. So this is like a step by step. If you don't understand X, you don't understand Y. So it is your task so that you are always ready to understand our next topic. So overlapping versus disjoint. So what is mean by overlapping? When a record is added here, super type, there's a possibility that a record is added to more than one of the subtype. One subtype or more subtypes. So then we say it's overlapping inheritance. But whenever you add a record to the super type, there's no such possibility of adding it to multiple subtypes. Maximum it can go into one subtype only. So then it is a disjoint. Is it clear? Of course, you should have get it cleared when we discussed that about 3 weeks ago, right? Not today. So today's task is designing the solution. So that is overlapping versus disjoint. So then we discussed there's a concept called total versus partial. So this can be disjoint to overlapping, disjoint to overlapping. That concept we have already discussed. But this is total. This is partial. Total inheritance, partial inheritance. So total inheritance means whenever we add a record here, there must be at least one record in one of the subtypes. So that means whenever you add a record here, there must be a record in one or more of the subtypes if it is total. But if it is partial, single line, when you add a record here, sometimes there's no record in the subtype. Or you can have records in the subtype, or you may not have records in the subtype. So then it is partial. But total, whenever there's a record here, you must have at least one record in the subtype. Again, if it is disjoint, you can have only one subtype record. Overlapping, you can have multiple records. that is combined. So therefore, ultimately, you can have four possibilities: destroy in total, overlap in total, destroy in partial, overlap in partial. Okay. So not null constraint means null values are allowed or not. For example, let me show you that using our access. Right. So let's create a table. Let's say employee, design view, say employee ID, e-name, say contact number, and salary. Now, by default, primary key is not null. Remember, entity integrity constraint, primary key must be not null and unique. But these are by default null allowed. Employee name, contact number, salary. By default, null allowed. Null means you can save it without value. But if you want to enforce not null, you need to see in access, you need to select. For example, I will say name is mandatory. So then I select e-name field and here uh, see whether you have field required. You can see required no, but you can select it, change it. It's a there's drop down required yes. If you pick required yes, that means it's not null. It is not null field. So now my employee ID is not null by default because it's the primary key. Employee name is not null because I set it, but I have not set it not null for other two fields. Right now, if I save this and enter data, of course, employee ID I need to enter because I did. Is it auto number? Did I set it to auto number? Yes, it's auto number anyway. Uh, so therefore, it will be saved. But name I must give, say Nimal. But other two fields I can save without value. So you can see no error. And if I close and open, now of course the auto number field has given this one, but I can save my record without contact name, number, and salary. If you want, you can have contact number and salary as well, right? With 0712345 6. Save. Now if I close and open, yes, it is there. Still, I make it salary null. No value means null. But I can't do the same thing for e-name now because I make it not null. If I delete this and try to save this, okay, so it allowed me to save it. I think it is saved as empty string. Okay, empty string. Okay, so that is strange. Let me double check. Design. Required DS. Yes, required DS, right? Maybe I have a default value. Okay, shall we do it for a numeric field? Say salary. I think for text, empty values are taken. So let's make it number and then I will say required DS. There's no default value. And then I will say required DS. Required DS. Okay, required DS. And now let's see. Close. Yes. Right now you can see already I can't save it because there's a already record with no salary. Okay. Do we want to continue anyway? Data is lost? Yes. Do you want to existing data to be tested in the new rule? No. Right. Now, if I try to save this, right? So let's add a name, only the contact number, and let's try to save it. You can see you must enter a value in the employee e-name field because it's not done. So it says you must enter a valid value for e-name field. So if I add a valid value like Rehana and save, now it says you must enter valid value for employee salary because salary is now not null field. But for the existing data, it doesn't check. But for the new data, it check. Say now I need to add. Right? Now I should be able to save it. But again, if I add a new record, say I only add contact number, again I will get the same errors. Fine. Name must have valid value. Okay. Then it will say salary must have valid value. Yeah. Say. But if I remove that constraint, I won't be getting that error. So shall we remove that constraint now for the salary? Design, select the salary, and here I will say required no. Required no. Now I will close it, save it. Now I should be able to save without salary. Say Raju, contact number, but no salary. No salary. Earlier it complained about salary. Now no errors. Still it will complain about name, but not about salary. If you type and make it empty, it doesn't check it because it's considered as empty. Right? But for the new one, if I just enter contact number, now I will get the complaint for the name, but not for the salary. You can see it says name must have a value, but not for the salary. Not for the salary because I make it salary null allowed. You can see now I can save. So that is called null constraint, whether null is allowed or not. Okay, whether null is allowed or not. Right. So let's get back to inheritance. So remember inheritance, what are the two concepts? Disjoint to overlap, total or partial. Okay, total or partial. So in the A-level ICT, so far they have not asked any single question about designing inheritance. Designing inheritance. But you never know because every time examiner try to ask something new, right? That is how they can make your exams challenging. Right? That is how they can make your exam challenging. Otherwise, your exam is not challenging. So therefore, there's a high possibility that maybe in the future or maybe in your year, they ask about possibly about designing inheritance. Okay, so that is why we are doing it. And that is why we are doing it. Okay, right. So there are few possibilities. Actually, there are three possibilities. Right, designing for the inheritance. Three possibilities. That is, sorry, there are four possibilities. Right, four possibilities. That is hierarchical multiple table for supertype and subtype. That is one solution. Single table with single type attribute. Single table with multiple type attributes. Non-hierarchical multiple tables for subtypes only. Multiple tables but no hierarchy. Don't worry, I will explain one by one. Because those are four possible solutions. And each solution has its pros and cons. Okay. But the most widely used approach is this first one, right? Hierarchical multiple tables for supertypes and subtypes. This is the most widely used approach. And this approach work for almost all the possibilities. Okay. But other approaches have restrictions, right? For example, these approaches may not work for some scenarios. So therefore, let's take the best solution, which work for all scenarios. Hierarchical multiple tables for supertype and subtype. Say we have inheritance employee. There are special cases of employee called secretary, technician, and engineer. Right? Say we have general case employee, but there are special employees like secretary, technician, and engineer. So if you go for this solution, we come up with three tables: employee table, secretary table, technician table, engineer table. Of course, if you have another subtype, you need to go for another table, right? So that means you have a table for the super type, you have a table for each subtype. So that is why we say hierarchical, because super type table is there, subtype tables are there, and of course it results in multiple tables, at least two tables. And this is the most general solution. Okay, this is the most general solution because it works for both total and partial, and also it works for disjoint and overlapping, right? Disjoint and overlapping. So therefore, this is general solution. So this is your employee table. You have the common attributes and the primary key. Maybe primary key is SSN, social security number, or employee ID, or whatever. Okay. So then for each subtype, you have another table. And it has the primary key of the super table and additional attribute for that table. Say secretary has typing speed. So only the typing speed and this is primary key. Say technicians have technical grade. So only that field and the primary key of the super type. Say engineer has engineer type. Only that attribute and common primary key. Okay. So then if your employee is engineer, there will be record here and there will be record here. Other two tables will not have records. And those two records will have the same primary key. So therefore, we can get the general employee details from this table and uh, specific the attributes of the engineer from the engineer table. And obviously, it work for both partial and total. If it is partial, there can be a record only in employee table, but none in the subtables. That is fine because that employee is not a secretary, technician, or engineer, a general employee. So that means partial. It works because we have the common super type table. And it works for total also because then there will be at least two records, one here and one here. And not only that, it works for both overlapping and uh, disjoint. If it is disjoint, there will be record here and there will be record in one of the tables. If it is overlapping, there will be record here and there will be multiple records here. Because overlapping means that, of course, in this case, it is disjoint. But if it is overlapping, let's assume an employee can be both secretary and technician. So then there will be record here and there will be two records here, but not in the other table. So this is the best or general solution because it works for any scenario. Any scenario. But if it is disjoint, you can even have a job type attribute. So that job type decide which table the other record will be. If the job type is technician, there will be record here and here. If the job type is secretary, the job type will be secretary here, and then the record is here and here. But if it is overlapping, don't go for job type or something like that because the record can go into multiple tables in the subtype. Okay. So that is the best solution. I can't say best solution, but I can say that it is the safest solution because it works for all the possibilities. Okay. But if you are planning for overlapping, don't you better not to have job type or this kind of a type attribute because a type can have only one value. Okay. Right. So that is one solution. Having table for each supertype and each subtype, and optionally have the type attribute here. So the second solution is you just have one table, just one table. You are not going to have separate table for supertype, subtype. So you just have employee table. It has a primary key, in this case SSN, because this example taken from textbook, which is printed in US. So they, just like our national ID, they call it social security number. And all the common fields, plus if there are any specialized field, those are also here, like typing speed, technical grade, engineer type, and so on. Okay. And again, if a particular employee is multiple type, you better not to have the job type because job type can't have multiple values. But if it is disjoint, yes, job type, then job type determines which field will be valid, right? Which field will be valid. Okay. But anyway, this is another solution. But this is not good for overlapping if you have a job type because you can't keep track of if particular employees of multiple type. So therefore, this is preferred for disjoint. And of course, this work for both total and partial. For example, if it's a general employee, the job type will be empty and there won't be data for any of this. Only thing is, may not work for overlapping because you have only one table. So the next one is say one table, but now you have multiple type attributes. Multiple type attributes. Like for example, it's basically good for overlapping. So we can see P flag. That means whether it's a purchase part. Right? Then M flag, whether it's a manufactured. If it is manufactured, M flag will be true. P flag will be false. If it is purchase, that means purchase part. If P flag will be true, M flag will be false. If it is both purchase and then do some modification, both flag will be true. So flag is true, the corresponding fields have meaning. So that is again one table, but multiple flags. So this is good for overlapping, and total. But you can use it for partial as well. Then both M flag and P flag will be false, right? M flag and P flag will be false. So you need to understand if someone give you the solution design, you must tell you for which kind of a scenario this work, for which kind of a scenario this is not good. Right. Our final solution is right. You go for multiple table, but this time you have table for subtype only. You don't have a table for supertype. Right. For example, there's no table called vehicle, but there are tables called car and truck. And both tables have the same primary key. Let's call it vehicle ID because vehicle can be car or truck. So this is a different solution, right? Because you don't have a table for Remember the first solution, we had table for car, truck, and vehicle. And this time you have table for car and truck one. So obviously this is not going when it going to work if it is partial. So partial means there's a vehicle which is neither car nor truck. So then you can't put it into car because it's not a car. You can't put it into truck. So therefore, if you see this kind of a solution, definitely you must say that this doesn't work if the relationship is partial, because it doesn't make sense to add a record to a car table when it is neither car nor truck. Maybe it's motorcycle. So therefore, this solution doesn't work for partial. And also this is better for disjoint. Disjoint. Okay. So that means this is better for total and disjoint. So disjoint means only record will be going to only one table. One table. Total means always record will go into at least one of the table because we have only subtype tables. Okay. Right. So how many solutions we discuss? We can see the best solution or the general solution is for the first one. This one. Because it works for all possibilities. All possibilities. Okay. But if someone present a solution, by looking at the solution, you must be able to tell what are the pros and cons of this approach. For example, if you have only one job type, you can say that definitely this is not going to work for overlapping. Okay, overlapping. And again, if you have multiple flags, yes, it works for both overlapping and partial. Sorry, overlapping and disjoint. Okay. And it works for both partial and total as well. Then both the flags will be empty or false. And definitely this one is not going to work for partial because you don't have a table for the super type. So likewise, you must be able to tell what is the drawback of this design. But this is the best design because this support almost all the scenarios. But only thing is, if it is overlapping, don't apply this job type. Or else you need to have multiple type fields because subtype it can belong to multiple subtypes. Okay, so likewise, you should be able to easily say what is good about this, what is bad about this, in what kind of scenario this table work, this design work. So that is all about designing, right? So that is why different people come up with different designs, and every design has its pros and cons. So that is why when we buy a vehicle, when we buy a phone, different designs. Right? Some people prefer to buy Apple phone, some people prefer to buy Samsung phone, some people prefer to buy Xiaomi phone. Sometimes they prefer to buy something else, but it is too costly. So if you look at why it's costly, maybe that design is better and costly to manufacture. So likewise, for different possibilities, there are different solutions. Just because Apple phone is good for you, maybe not good for me. For example, if someone give me Apple phone, I will say, no, I don't need Apple phone. I prefer to have Android based phone because I am more into the software development side and so on. I need to test my mobile apps, and most of the people use Android phones. So therefore, first I want to make sure that my app work in Android, not in Apple. So likewise, for me, I prefer to go for Android phone with my requirements, and I prefer to have lot of ease with lot of apps. Most of the time, apps first support Android and then support Apple. So likewise. Even lot of devices run Android, not Apple. So therefore, there's nothing called what is the best solution, best design. It all depends on your requirements. So that is why there are so many possible design, right? Sometimes it's good for particular scenario, right? Right. So remember we at the very beginning I told you, but don't take this last topic I discussed very seriously because examiners have not asked a single question about designing inheritance so far. But at the same time, when it is not asked, there's a possibility of they ask also. But it's not going to be asked. I can't say it's, for example, normalize how to design one-to-many relationship. 100% of the time you must know. Right? Your second paper question definitely will you need it. But this knowledge, you may need it, you may not need it. You may not need it. Maybe 15% you may need it. 85% you may not need it, or examiner will not ask question on this. But at the same time, that 50% is also important for you, right? Right. Our final subtopic is physical design. So remember, I told you that designing is two step: logical design, physical design. So logical design start after you decide what kind of approach you use. That means you have decided the database type, whether it's relational database, NoSQL database, object-oriented database, you have decided, but you have not committed to what database. So far we discuss under the assumption that we are going to use a relational database, right? That is how we so far did our discussion, designing. Even object-oriented last subtopic, how to support it with relational databases. So once you do your logical design, right? So then you move on to your physical design. So now you have done your logical design, right? You have identified your tables, their primary keys, foreign keys, any other constraints, some referential integrity constraints, some domain constraints, and blah, blah, blah. So now you move on to the second step. But at the same time, remember there's a small subtopic related to logical design, that is normalization, that we will take separate. So that means that we are going to look at a bit of physical design and then we'll come back to bit of logical design again. Okay. But now we officially move on to the physical design. Say now you have the relationships, foreign keys, primary keys, one to one, one to many, all these things you have identified. Right. Now you will decide, okay, should we go for Oracle? Should we go for Microsoft SQL? Should we go for MySQL? Or even if it is a very small database with single user or something, even should we go for Microsoft Access? So that decision is taken depends on the performance, security, and other factors are considered. So once you decide that, so the rest of the thing is refining your logical design, refining to suit your selected database management system. So that is called physical design. Okay, physical design. So what kind of things you consider when you do physical design? Obviously, what is our database type now? What is our database management system? Because different database management systems support slightly different features, different data types, slightly different way of doing things. Some database management systems support some advanced concepts which we can use. And also we think about the performance, security, backup. Okay. Because different database management systems support those in slightly different manner. So then what we do is we don't do a separate designing. We just refine your logical design. Okay. So we can decide what is our storage structure, what kind of files are we going to use. There are different type of files. Are we going to introduce index files to increase the performance? Index files are used to speed up the query by your file system. But it depends on your database management system. And each database management system specify what are the data types available. For example, uh, maybe in MySQL, there's a data type called varchar. Another database type, there's no varchar, maybe just a char. In one database type, they can have both float and double. But another database management system, maybe they have only float, no double, or only double, no float. So likewise, there can be slight differences. So then you need to decide according to your database management system, this is our data type. And also how to do your backup and recovery, transaction handling. Those are part of the physical database design. But in your A-level ICT syllabus, we don't discuss how to do that. Just you need to aware that end of the logical design, you need to think about the physical design and do certain things which is beyond our syllabus. So once your physical design is done, then you are ready for deployment of your database. Okay. Integrate it to your applications. And physical design, what are the main key attributes? Performance, security, right? Backup and recovery, and so on. And we are done with design. But when we say we are done with design, there's a small topic we take separately, that is normalization. Other than normalization, which is part of the logical design, we are done. Okay. So any questions? Any questions? So database design is done, but we need to look at the normalization separately, which we want to start today but not finish it. Okay. Right. Any questions about uh, designing? Because every year there's second paper question, either structured or always there's a structured question. Sometimes both structured and uh, sorry, always there's a as essay question. Sometimes both essay and structured. Always there's at least 5 MCQs. That is a different story. Right. So we'll take 5 minutes break. Okay, 10 minutes break, and we'll move on to normalization of data. So now it's 5:05. We'll start at 5:50. Normalization. The note is available in Google Classroom. Okay. Okay, so let's continue. Right, so now we move on to normalization of data. Normalization of data. So for that, I have given you a separate note. Right, data normalization. Okay, data normalization. Right. From this, sometimes you get second paper question or part of just one sub question, or sometimes you get one MCQ. Most of the time, one MCQ and sometimes a small part in structured essay paper. Okay. Right. Data normalization. So as I told you, this is again part of the logical design. Part of the logical design. Uh, so what is data normalization? Data normalization is organizing the data into relational model. So therefore, in a way, we have been doing this. So overall designing is also part of the normalization. Okay. So therefore, in a way, we can say that we have already done this or continue doing this because organizing the data into relational model or best way of organizing data into relational model. That is why we have been deciding primary keys, foreign keys, connecting tables, what is the best way to model weak entities, right? So therefore, we have been doing that, right? But at the end, we want to double check whether we have done it properly. We have done it properly. This is like a checklist now. Checklist. So, of course, if you have done it properly, you will find that you have already done normalization. So that is what happened when you see talented designer design the database, and he will always find that okay, my data is in normalized form. Okay, but people can make mistakes, right? And also, if you are new to designing, like you guys, sometimes you may not have done it properly. So this data normalization is a way to double check whether you have done it properly, and if not, fix it. But ideally, if you have done it properly, you will not find any issue and you will just verify that yes, it is normalized. But at the same time, if you have made any mistakes during the data normalization, you can fix those. Right, fix those. Okay. Right. So therefore, data normalization is part of the designing. So data normalization, if you have done it properly, at the end, you will find that your checklist is all green. At the same time, if there are mistakes, it gives you an opportunity to fix it so that your design is in good form. Okay. So if you have done proper normalization, that means if you have not violated any normalization rules, and if violated, you have fixed those, the end result, it reduces data redundancy. Redundancy means duplication. So you can't say no duplication. Rather, you have the minimum duplication, minimum essential duplication. And also you will have good integrity between your data. Integrity means there's a data is very well related between tables. So the end result of normalization or end result of good design is minimum redundancy, good integrity. Minimum data redundancy, very good data integrity. Simple. Integrity means relatedness. Redundancy means duplicate. Less duplication, good relatedness. Okay. So these are two tables, and these are two tables having some design issues. And design issues. That means someone has not done it properly. So design issues means you have duplicate data. Data is not properly integrated, connected. There are ambiguities. Okay, duplication, and so on. So this shows some of the possible issues. Actually, not possible here. These are the issues because these tables are not properly normalized or properly designed. For example, these are two tables. Two tables. So this is the birth certificate table. This is driving license table. Now you can see here you have names. So maybe you don't know whether this is the same guy or two different guy. Same guy or two different guy. Maybe K Silva is Kapila Silva. Because there's no connection between birth certificate table and driving license table. Right? Maybe date of birth is also the same. Still, can I say that K Silva is Kapila Silva? No, right? Still, there can be two people. Okay. Anyway, that is one possible issue. One possible issue. There can be some other issues as well. And maybe those are the same date records, but somehow the date of birth values are wrong. Right? Maybe it's K-Silla is Kapila Silla, but someone has made a mistake in one of the table. The date of birth is wrong. So likewise, there can be so many possible issues. But if you do normalization, you will not have those problems anymore. Right? So this is just some of the issues, not all the issues. Okay. So you can see that after designing, someone who has good understanding about database designing can come and show you that these are some issues with your design. So normalization is like that someone question your design. That but it's actually not someone. There are rules that you can double check whether it complies with first normal form, second normal form, third normal form, and so on. So if those rules are not violated, you have better assurance that your design is pretty good. Still, we can't say it's 100% correct, but at least it has validated your basic checks are done against the basic checks. Right. So the result of normalization is normalize ER model or normalize logical design. Normalized logical design. Okay. Actually, we do the physical designing for the normalized logical design. Right? We do the physical designing for the normalized logical design. That is why I told you, though we discuss about physical design, uh, we are going to do another part related to logical design, and that is this. Okay. Right. As I told you, if you are a very experienced designer, when you do your designing naturally, and also when you are aware of the normalization rules, you will naturally make your design normalize. That is what happens when serious or senior people, experienced people do their design because they are aware of the data normalization rules, best practices. Naturally, their design is going to be normalized. But anyway, they can double check, and most of the time they will find that yes, no issue. But especially if you are new to database design, because everyone is not experienced, everyone is not very serious. So therefore, we can use data normalization rules as a review and refine solution. Right? Double check, checklist, checklist. Okay. So how do we do the data normalization? I told you experienced people will naturally apply normalization then and there. But let's do it as a separate process. Say after designing. So after the designing, that means you have decided what are your primary keys, foreign keys, connecting tables. You have thought about inheritance, modeling the inheritance. You have thought about, you have designed your weak entities, multi-valued entities, composite attributes. All those things are now in your tables. So now how do you do it? You do normalization as a sequential process. Okay. So that means you are supposed to check the first normalization form. If it is not violated, you need to fix it. If it is not violated, or if after fixing it, then only you can look at the second normal form rules. Then again, if it is violated, you fix it. Or if it is not violated, you go to the third normal form. That means you do another set of testing, another set of rules and see whether it's compliant. And again, if it is violated, you fix it. And if it is not violated, you are done. So that is why we say it's a sequential process. You can't come and or first check second normal. No. First check first normal, and if it is satisfied, then only check the second normal. Then only you check the rules related to third normal. You can't just take randomly. You can't say that I will first check the third normal form, then I will check the first normal form. It doesn't work. It doesn't work. Okay. That is what is mean by sequential process. Right. So therefore, let's look at sequentially. Before moving to the checking of normalization, we are going to look at few theoretical aspects related to normalization. So then we can look at the normalization process. Right? So we are looking at two theories, atomicity and dependency. Atomicity of data, functional dependency of data and relations. Those are very simple concepts, but you need to be serious to understand this. Right. So let's take the first concept, atomicity. You know what is the meaning of atom, right? Atom means you can't further divide. Atom, you can't further divide. Right? If you once you get into the hydrogen atom, if you further divide, you don't get a small element. Of course, you get electrons and protons, but no smaller element. So then we say it's a hydrogen atom. Parama Paramanuva, Parama. So there's nothing smaller than that. You can't break it further meaningfully. So atomicity of data means your field or your column or attribute has a single value. There's no possibility of multiple values. So if there's a possibility of multiple values, that means it is not atomic. If it is not atomic means it's going to violate normal forms. Okay. For example, you can see there's a field called skills. And a person might say, I have skills in different languages. Right? There's no guarantee that person will say, I have only one skill, right? But you have field called skills in your table. So that means that field is not atomic. But if you take something like salary, you can't say that I have two salaries for a one job, right? You say, okay, my salary is 55,000. You can't say my salary is 55,000 and 70,000. Not for one job, right? So then salary is atomic field, right? Maybe your name is atomic because you can't have two names. I mean the formal name. You can't have two date of births, but you can have two skills. You can have two contact numbers, right? Then if you have field called skills, if you have field called contact numbers, that means it has violated atomicity. Now you can see why did we, when we have multi-valued attributes, we took it to a different table and create a one-to-one relationship. Actually, that was done to preserve the atomicity or preserve the first normal form. Now you can see, I told you that if you have done your design properly, it will be in normal form. So of course, if you have identified your multi-valued attribute and take it to a different table, then your fields are atomic. But if you mistakenly forget it, now you will find it. You will find that okay, I have a non-atomic field, and later you will find that okay, my table is not in first normal form. Okay, is it clear? So fields must be atomic. A field cannot have for one record multiple values. For one record, multiple values are not allowed. So the second concept is actually the atomicity is related to first normal form. The second concept is functional dependency, which is related to second and third normal forms. Okay. Dependency. Do you know the meaning of dependency? Depend on. For examples, you as a child depends on parents. You depends on parents, but not parents depends on you. Okay. So when you edu in a studying, you depends on teacher, but not teacher depends on you. So that is called dependency in general term. But here it's slightly different concept. So therefore, don't think that the same concept is discussed here. No. In we look at the functional dependency. Dependency. Okay. So here, though we use the word dependency, actually the technical word we use is functionally determined. Functionally determined. Okay. So this is the notation we use. So this says A determine B. A functionally determine B. Like your father's name functionally determines your name, child name, because you get the surname of your father, right? Not child's names, the function determines father's name. So this is like that. Determine. A determine B. A determine B. And this is related to the concept of primary key. Okay. And this is later you will find that this is related to second and third normal forms. So in database theory, we can say that A determines B if for each unique value of A, there is exactly one value of B. Simple as that. If you want to check whether if A determines B, just check whether for one value of A, is there's only one value of B. Then you can say A determines B. Otherwise, you can't say like that. Okay. For example, you can see that for one value of A, there's only one value of B. For one value of A, there's only one value of B. For one value of A, there's only one value of B. Yes, for two A values, there's only one value, but that is fine. So this says for one value of A, there's only one value of B. For one value of A, there's only one value of B. But you can see that for one value of A, there are two values of B. So that means A does not functionally determine B. A does not functionally determine B. But if for one value of A, if there's only one value of B, we can say that A determine B. A functionally determine B. Okay? Simple as that. Very simple concept if you understand. But sometimes what happens is students try to learn these concepts without understanding the reason, okay, theory behind that. Right. Now let's see whether there's a functional dependency between these three fields. So for one ID number, if there's only one name, we can say that ID number function determine name. That is correct, right? For one ID number, one name. For example, my ID, if you take my ID card, there's an ID number. And for that ID number, only my name is there. So that ID number can have your name and someone else's name. Because that is why when they issue an ID card, they issue only one ID number for one person. So you have a laptop, I have a laptop. Your laptop's serial number must be unique. It can't be same as my laptop's serial number. Right? So that is why we say serial number functionally determines the laptop. Right? Is it clear? For example, when you go to A-level exams, there are candidates. Say there's examination or candidate number. Your A-level candidate, you get a number, exam number. So then your name. So can we say that your index number functionally determine name? Yes or no? Yes or no? Say index number, that is exam index number, functionally determines name. Yes or no? I need straightforward answer. Yes or no? That means for one index number, if there's only one name, yes, index number function determine name. But for one index number, if there are multiple names, that means index number does not function determine name. Anyone? Yes or no? Determine no not for this example. Take your A level. You have already done your O level, right? Take your O level. One index number can there be multiple names? Name means full name or just one name if they have done it in a proper way. Don't assume that they have made mistakes. Yes, right? For one index number, there must be only one name. Otherwise, they have messed it, right? They have messed up the system. Of course, they don't do it. That is how you double check. What about this? Index number functionally determines date of birth. Yes or no? I just need simple answer. That means for one index number, there must be only one date of birth. Again, this is say O-level exam. Because sometimes you get confused about these concepts. Sometimes you think the other way. When I say X to Y, you think about Y to X. Do you agree with this? Index number functionally determines date of birth. Because without understanding this, no point going for normalization. So the answer is yes, because for a particular index number, there must be only one date of birth. Because for a particular index number, there must be only one student. Because two students can't have the same index number. It's only one student, so that student must have only one date of birth, right? One person cannot b- born in more than one days. That is how you check it. That is how you check it. You need to use your common sense and logical thinking. Can you say like this? Date of birth functionally determines name. You just need to say yes or no. Yes or no. Simple answer. So there's a question, but two students can have the same date of birth date. But what I wrote is not that. What I wrote is student register index number determine. That is why I told you when I say index number determines date of birth, you only look at this way. So I didn't write it like now I have written like this. Now this is different from this question. Now what I'm asking is date of birth determines name. Do you agree or not? That means yes or no. That means for a given date of birth, there must be only one name. Say these are the O-level students. If so, you need to say yes. If not, you must say no. Okay. Anyone? So definitely no, because there can be multiple students of same date of birth. So therefore, by looking at the date of birth, you can't say exactly what is the name. Because maybe Nimal has born in the same date, Kamal has born in the same date. Okay? Right. Because we are going to use this concept in second and third normal form. Okay. And if you want, you can extend this. Now, so far we have been using it for fields. You can extend this for tables also or entities. Entities. For example, employee determines department. Now it's not, those are not fields, those are tables. So that means if on for one employee, if you have only one department, this is correct. Do you agree that one employee has one department, right? In general, we can't say that that employee is working in two departments right now. Maybe he will be transferred to the other department later, but still he is under one this department. So this is correct. But this is entity related, entity level functional dependence. Say if I know the student, can I determine the course? Yes, if student do only one course. But if student do register for multiple courses, no. So this is under the assumption that one student register for one course. So therefore, this is not a very good example. Also, this is under the assumption that one student register for one course. But this is not correct because department can have many employees. So just because, for example, if I go to a particular company and tell, right, there's my friend, he works in HR department, so then they can't find out who is it. Maybe there are 10 HR department employees, right? 10 HR, so then you need to check one by one. First employees come to you and you say, no, this is not my friend. Then the second guy, right? But if you go to the company and say, my friend is his employee ID is this, which department he works on, then they will say, okay, he works in this particular department. So if I go to the institute and ask my friend is doing this particular course, can you tell me who is it? No, they can't tell you exactly because there can be multiple students. But by looking at the student ID, they might say, okay, this is the course. This is the course. But at the same time, there's a possibility that multiple courses are also there. That is, if there's a policy saying student can register for multiple courses. So that is why I told you that this is correct under the assumption that student can register for only one course. So that, okay, that I should have mentioned that assumption. Right. So then there are important properties when it comes to dependency. Right? Dependency. The first property is A determine A. That is obvious. Right? If my name is Nimal, of course, Nimal determines that it is Nimal. That is obvious, right? That is why we call it axioms. Axioms means pratyaksha. එකටම තේරෙනවා. If someone's ID card number is, say, so I can say, yes, his identity card number is this. So that is called reflexivity. It's a property of functional dependence. A determines A. Just like NIC determines name, yes, because for one NIC there must be only one name. Just like NIC determines date of birth, right? We can say that NIC determines NIC. That is obvious. Okay. So the second axiom says transitivity axiom. If A determines B and B determines C, then you can write A determines C. Okay. For example, if I know the student ID, then I know the course ID. Let's say if I know the employee ID, I know department ID because one employee work for one department. Let's assume one department resides in one location. So then when I know the department ID, I know the location. So just because you know the employee ID, now you know that, okay, this guy is working in that particular building because the employee ID determines the department ID. Department ID functionally determine the location. So therefore, employee ID functionally determine, I can say that employee ID functionally determine location. Is it clear? Is it clear? Is it not clear? Or do you don't agree with it? That is also fine if you don't agree. If you have doubts, you may feel like it's not correct. You can question. Think about it. Okay. It makes sense. Does it make sense that A determine B, B determine C means A determine C? Right. So these are some examples. We call them Armstrong axioms. Don't worry about the name. Right. So this is reflexivity. Name determine name. Salary determine salary. This is transitivity. Order ID determines supply ID. Supply ID determines supply name. So then order ID determines supply name. Right. Now you can move on. We can move on to normalization because we know what is atomicity, what is functional mean by functionally determined. Again, as I told you, we need to go this sequence only. Otherwise, it doesn't work. Right. First normal form. That is the easiest to determine. And it is related to the concept of atomicity. So the first normal form says when you take a table or relation, all the fields must be atomic. If there's at least one field which is not atomic, that table has violated first normal form. If all the fields are atomic, then it is in first normal form. If a table is not in first normal form, we can say it is not in normal form, so we can say it's in zero normal form. Zero normal form means it is not even in the first normal form. Okay. And if this is violated, that means if it is not in first normal form, you need to take those non-atomic fields to separate table and create one-to-many relationship. If you have two such situations, you need to create two tables and create two one-to-many relationship with your parent table. Okay, so first every normal form says what is the issue, what is the solution. So once you apply the solution, it's no longer violating that. Okay, so once you, that is the beauty of that, right? So you find it there's issue, you fix it. Now you don't have that issue. Right, so this is an example. So we have table. Let's say this is customer table, customer ID, primary key, name, contact numbers. You can clearly see that multiple values are possible. Just one name, right? One name. But there's a possibility of giving multiple contact numbers by that guy. So that means this is not in first normal form. So when you see non-atomic field, you can straight away say it's not in first normal form and you don't need to think about second, third, and other thing. If it is not in first normal form, you don't think about check the second, third forms. So what is the solution? Take this to a different table and create a one-to-many relationship. This is the solution. So now your customer table doesn't have the contact number. It has only customer ID and name. The contact numbers, we have taken it to a separate table and you have created a foreign key that is the primary key of this original table, foreign key. Because your contact ID must be related to the customer. So you can see these two contact numbers are for customer ID one. These are the Nimal Pereira's contact numbers. Yes. But Kamal Gamage has only one contact number, right? Second one. And again, Ravi Gunasinghe has two contact numbers. Sometimes he may be having three contact numbers, four contact numbers. Every time now it's a new record. So this is the issue, but now we have solved it, and now our two database or the two tables are in first normal form. Is it clear? Is it clear? Okay. Problem. Therefore, it's not first normal form. Now solved. Now it is in first normal form, these two tables. And this is another example. Say product, maybe vehicles, product name, price, and color. You can see that same product can have multiple colors. Maybe that vehicles comes in three different possibilities. This Maruti comes in two different colors. And maybe this Panda is only on one color. But in general, this is not atomic now. Maybe the price is same. That is why maybe they are like that. But can't help. This is violating first normal form. So what is the solution? Take these to a separate table and create a one-to-many relationship. So now we have only these three fields. This is no longer there, but it is in a different table where your primary key is the foreign key of that table. So therefore, still we know that Alto has white and black. Sorry, white, black, and blue. Maruti has white and black, whereas Panda has only white color with maybe with us. Maybe in our car sale we have only white Panda. Is it clear? Because this is the easiest to understand as well. Right. Second normal and third normal form we will look at in the next class. Okay. We will look at in the next class. Then we'll move on to we need another half an hour to finish it. Then we'll move on to SQL. SQL need two yeah SQL need two sessions. So then database is done. Then we need to do a bit of past paper questions before moving to programming. Okay. Right. Any questions? Because we discussed very serious stuff today. And when we discuss very more and more serious stuff, now you must be more and more serious, responsible, right? Logical thinking, critical thinking. So it must be improved. That is one of the purpose of learning advanced concepts. So you become more serious, talented person. Okay. Right. So if you don't have any questions, we'll stop. Okay. Right. We'll stop at this point.